Example 7. Consider the experiment of tossing a coin. So when you toss a coin, there may be head or tail occurs. Then if the coin shows head, toss it again. Suppose you are getting head. If the coin shows head, then toss it again. So when you toss, you may get head or tail. So in that case, you get two outcomes. Now, and if it shows tail, so in the first toss, suppose you are getting tail, then what to do? Then throw a die. Then throw a die. So suppose you are getting tail in the first throw of the first toss of the coin, you have to throw a die. So in that case, you have to throw a die. So when you get tail, you have to throw the die. So what are the possibilities? T1, T2, T3, T4, T5, T6, etc. T6, like that. T6, these are the cases. So these are the possible outcomes of the experiment. So first you have to understand what is the experiment. Here only not the single toss of a coin. The experiment is not over. First toss a coin. So consider the experiment of tossing a coin. First toss a coin and then you may get head or tail. Now if you are getting head, what you have to do? Again you have to toss the coin. Toss it again. Suppose you are getting head, then you have to toss it again. So the possibilities are, so then in that case, the experiment is over. Suppose you are getting head in the first toss, what you have to do is you have to toss it again. So in the second toss, it may be head or tail. So the possible outcomes are head, HH and HT. So in that case, the outcomes, only two outcomes are there. Now suppose the other case, suppose you are getting tail in the first toss, then you have to throw the die. So the possible outcomes are T1, T2, etc. T6. So what is sample space? So yes, sample space equal to HH, HT. Then suppose you are getting T in the first toss of coin, then you have to throw the die again. So T1, T2, T3, T4, T5, T6. So these are the elements in the sample space. HH, HT, then T1, T2, etc. T6. This is the sample space. So to write the sample space you have studied last year. So understand the experiment and write the sample space. Then what is E? Find out what is E. What is the event E? E. What is the event E? Find the conditional probability of the event. So for this event we have to find the probability. That is the die shows a number greater than 4. Die shows a number greater than 4. And what is that? Die shows a number greater than 4. What are the elements? Die shows a number greater than 4, T5 and T6. Only that. See, not only that two cases. That is T5, T6. Die shows a number greater than 4. Only these two cases. Now what is F? Event F. What is a given event? Given that there is at least one tail. That is a given event. At least one tail means one tail or two tails. So which are the events? At least there is at least one tail. There is at least one tail. So F is the event. There is at least one tail. So write the event as a sample space. As a set. At least one tail. So minimum one tail. That means one tail and two tail you can write. HT, there is one tail. Then here T1, then T1 etc. T6, T1, T2 etc. T6. So one tail and only one tail. In all cases one tail. So only these are the cases, HT and T1. So there is at least one tail. So HT, T1, T2, T3, T4 etc. T6. So we wrote both E and F. Here also there is some specialty for this question. We did example 17, same type. So only note down these questions. Here the sample space, see all the elements, elementary events have not the same probability. See here HH, what is the probability of head HH? Here, what is the probability of the element HH? Probability of this HH. That means probability of getting head in the first toss, that is 1 by 2, into what is the probability of getting head in the second toss? 1 by 2. So 1 by 2 into 1 by 2, 1 by 4. So probability of HH, 1 by 4. What is probability of HT? That is also same. 1 by 2 into 1 by 2, 1 by 4. Now what is probability of T1? So this is same as probability of HT. HT. That is also same. Now what is probability of T1? Probability of getting tail in the first toss of a coin, that is 1 by 2. Head or tail, only two possible outcomes, head and tail. So 1 by 2. But what is the probability of getting 1 in the throwing of a die? That is 1 by 6. So 1 by 6, that is equal to 1 by 12. Like that, this question has that specialty. The elements, all the elements of the sample space have not the same probability. They have not the same probability. So that is the specialty for this question. So we cannot directly write number of E by number of S, or like that we cannot write. That is the thing here. You have to remember. So these are the, we wrote E and F. Now we can write E intersection F. What is E intersection F? E intersection F equal to common elements. What are the common elements of these two? Here T1, T2, etc. T6. Here T5, T6. So T5, T6 is here also. So intersection is T5, T6. T5, T6. Then, now we can find the probability. What is the probability of, here we cannot directly write number of E intersection F by number of S. I told you, here we have to find out the probability of each element, then we have to add. So now we will find, here I told you probability of HH, probability of HT, that is 1 by 4. Probability of T1, T2, T3, etc. T6. All these have same probability from T1 onwards. They have the same like this. T1, T2, 1 by 2. Probability of getting T, tail, 1 by 2 into probability of getting 1, 1 by 6. 1 by 2 into 1 by 6, 1 by 12. Similarly, probability of T2, 1 by 2 into 1 by 6, 1 by 12. Probability of T3, that is also same. 1 by 2 into 1 by 6, 1 by 2 into 1 by 6. For these elements, same 1 by 12. So like that we have to find out the probability of each element. Then we have to add probability of all the elements. Then we get the required probability. Now we will find the probability of, so now we find probability of E intersection F. We want to find probability of E given F. So for that we have to find probability of E intersection F and probability of F. So separately we will find probability of E intersection F. That is, see, this is E intersection F. So we have to find out probability of T5 plus probability of T6. Find out the probability of each elementary event, then you add all that. So here that is equal to probability of T5 plus probability of T6. So probability of T5, 1 by 2 into 1 by 6, 1 by 12 plus 1 by 2 into 1 by 6, 1 by 12. That is 2 by 12. Now you have to simplify. Now we want to find probability of F. We know probability of E given F, probability of E intersection F by probability of F. So now we will find probability of F. Probability of F. Probability of HT, that is 1 by 2 into 1 by 2, 1 by 4. So I am going to write directly probability of HT plus probability of T1 plus probability of T2 plus etc. probability of T6. All we have to add. So probability of HT, that is 1 by 4. 1 by 2 into 1 by 2, 1 by 4. Plus here 1 by 2 into 1 by 6, that is 1 by 12. Like that, how many are there here? 1, 2, 3, 4, 5, 6 are there. So 6 times, for these probabilities are same. T1, probability of T1 is equal to probability of T2 equal to etc. probability of T6. All these have probability 1 by 2 into 1 by 6, 1 by 12. So how many 1 by 12 we have to write? Here 6 1 by 12, 6. So 1 by 12, 1 by 12 plus so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. For these 6 elements, 1 by 12. And for this HT, probability is 1 by 4. Now we can add. Here we can multiply by 3. So 3 by 12. 3 by 12 plus. Here there are 6 by 12. So here 6 by 12, that is equal to 9 by 12. Now we can find the probability. Therefore probability of E given F equal to probability of E intersection F divided by probability of F. Probability of E intersection F, that is 2 by 12 divided by 9 by 12. By 2, that is equal to 2 by 9. So probability of E intersection F 2 by 12, probability of F 9 by 12. So 2 by 12 divided by 9 by 12, that is equal to 2 by 9. Okay.